All right, let's get right into it. Today, we are cracking open that black box of modern AI. We're going to figure out the one single idea that makes something like ChatGPT even possible. It's a question that honestly sounds like it's straight out of science fiction, right? How can a bunch of lines of code write poetry? How can a machine, just a set of instructions, suddenly generate creative text, translate languages, or even write more code? I mean, how does something so rigid produce something so fluid and, well, so human?
Well, the answer is kind of surprising. The magic here, it's not some single, impossibly complex algorithm. It's actually a pretty simple idea, just scaled up to an incredible size. So this is the story of the T in ChatGPT. We are going to break down that T, what it is, how it works, and seriously, why it changed absolutely everything. Let's dive in.
Okay, first things first, what does that T actually stand for? It stands for transformer. And a transformer is the fundamental, like the Lego brick, the compute block that powers these incredible models. So here's the basic idea of what happens inside something like ChatGPT. You type in a sentence, right? The model first chops it up into little pieces, words or even fragments of words. Each one of those little pieces then gets turned into a vector, which is really just a fancy way of saying a list of numbers. Then all those vectors get stacked up into a big grid of numbers called a matrix. And this matrix is what gets passed through what's called a transformer block. And then it just does it again, and again, and again. For a model like GPT 3.5, this happens 96 times, and for GPT-4, even more. Okay, so wait a minute. All this number crunching, it sounds pretty mechanical, doesn't it? It doesn't really sound like thinking. So where does the actual intelligence come from? To get a feel for this, to really build some intuition, we're going to take a step back in time to a huge breakthrough in computer vision that happened back in 2012. We're going to talk about a model called AlexNet. Now, ChatGPT learns from text, obviously, but AlexNet learned from images. And what it learned gives us this brilliant visual way to understand what's actually going on deep inside these networks. So check this out. The very first layer of AlexNet, it learned to do something super simple. It just detected basic stuff like colored blobs or edges at different angles. But then the next layer took those simple edge detectors as its input and learned how to combine them into more complex patterns, things like textures or corners. And the layer after that, it combined those textures and corners to recognize even more complex objects. This is the whole key right here. Complexity is built up, one layer at a time. And here's the part that is just mind-blowing. Researchers found that by the time you get to the fifth layer, the network had actually developed detectors for incredibly high-level concepts, like faces. But, and this is the kicker, nobody ever programmed it to look for a face. No one told it what a face is. It figured it out completely on its own just by looking at millions of labeled images. It learned that faces were a useful concept for understanding its world. This is what we call an emergent property of the system. Okay, so now we get it, right? Stacking simple layers on top of each other can build up this really complex understanding. So let's take that idea and bring it back to language and look at the one specific trick that makes transformers so ridiculously powerful. So before transformers came along, AI models read text kind of like a person does, one word at a time, in order. The problem with that is, by the time the model got to the end of a really long sentence, it might have kind of forgotten the context from the beginning. Transformers completely changed the game. Instead of reading one word at a time, they see the entire sentence all at once. And this lets them do something amazing. They can weigh the importance of every single word in relation to every other word. This powerful mechanism is called self-attention. So what is it? Well, imagine the model is looking at the word it in a sentence. Self-attention is what lets the model scan that whole sentence and ask, okay, which other words are most important for me to understand this specific word? It's how the model builds this rich map of relationships and context within the sentence. Now, if you look under the hood, the process looks, well, it looks pretty complex, like this diagram from the original research paper. But here's the secret. At its very heart, it's just a single mathematical operation, a matrix multiplication. That's the engine that allows every single word to interact with and influence every other word. It's the math that's calculating those attention scores we were just talking about, figuring out which words matter most to which other words. All right, so we've got this amazing self-attention mechanism. Now let's see exactly how it fits into that repeatable building brick, that Lego block we mentioned at the start, the transformer block itself. And here it is. This is the blueprint. and input comes in at the bottom. The first thing it does is pass through that multi-head self-attention, or MHSA. That's the cool trick we just discussed. Then it goes through a second part, a simpler, more standard neural network called an MLP. That's it. Self-attention, then an MLP. That is the entire building block. And what's so fascinating about this is that it's not all brand new cutting-edge tech. That second part, the MLP, or multi-layer perceptron, that's an idea based on the perceptron, a learning algorithm that was first cooked up way back in the 1950s. So the real breakthrough here wasn't inventing a bunch of new parts from scratch. It was about arranging these existing ideas in this new, incredibly effective architecture. Okay, so we've unboxed the building block, we get its main components. Now for the final and maybe the most important piece of this entire puzzle, scale. So you remember that transformer block we just looked at? Well, a model like GPT 3.5 takes that exact block and it just stacks it, one on top of the other, 96 times. The real intelligence isn't in any single block, it's what emerges when you stack them this deep. And the scale we're talking about is just, it's hard to even wrap your head around. Back in the 90s, a pioneering model for computer vision had about 60,000 parameters. Then AlexNet in 2012 jumped that by 1,000 times to 60 million. And today's biggest models have over 1 trillion parameters. That's more than 10,000 times larger than AlexNet. This absolute explosion in size is directly linked to their incredible and sometimes unbelievable capabilities. So you have to ask, why now? What made all this scaling possible all of a sudden? It really boils down to two main things. First, massive amounts of data. For vision models, it was a dataset called ImageNet with over 1 million labeled images. For language models, it's been huge chunks of the entire internet. And second, massive compute power. The rise of GPUs, graphics cards, for general-purpose computing gave researchers something like 10,000 times more number-crunching power than they had just 15 years before. And that brings us full circle, right back to our original mystery. The intelligence isn't explicitly programmed into any one of these components. You could even say the individual operations are, in a sense, pretty dumb. But when you combine these simple operations and you scale them up with massive data and massive compute, something truly incredible emerges. Intelligent behavior is the result of that complexity, not of some grand top-down design. You know, when you look at it, this whole journey from AlexNet to ChatGPT has really just been the story of scaling one core idea. And it really makes you wonder, are we just getting started? We've seen what happens when you scale these simple blocks by 10,000 times. So what happens with the next 10,000x?